Hey, welcome to this lesson where we will be covering event graphs for Blueprint classes, and we will also be looking at setting up custom input mappings for player input. So we want to start adding some input to control our player pawn. In the previous section, we were just utilizing the level blueprint for our blueprint programming. However, Blueprint classes have their own event graphs that we can code directly into. We can find the event graph for our player pawn by switching from the viewport tab to the event graph tab. So this is the event graph. It looks the exact same as the level blueprint really. However, anything we code here is contained directly in this blueprint class. And again, blueprint classes are reusable, so it makes the coding side of things really powerful. If we coded a single blueprint class and placed 20 of them in our level, all 20 of those blueprints would execute the same code. You don't have that flexibility in the level blueprint. And the issue with the level blueprint is that any code you make is stuck in that level. So really, you would only want to use the level blueprint for very specific level events. There's some things that function in a slightly different way when we compare a blueprint class to the level blueprint. We know that we can select actors in our level, and then in the level blueprint we can right click and create a reference directly to the actor selected. But look what happens when we do this with a blueprint class. Even though the actor is selected, there is no option to create a reference to the selected actor. This is simply because you can reuse class blueprints in different levels. If we reference an actor in one level, that actor might not exist in another level. This doesn't mean that blueprint classes can't have any references to actors. You can absolutely do that, but what I'm saying is you just can't use the same simple method to reference them as you do in a level blueprint. So what's the first thing we want to do in the event graph of our player pawn? Well, we want to start by making the class respond to player input, so the player can control and move the pawn around the level. In section 1, we saw that we can right-click in the event graph and we can go to the input category, and under the input category we can find input events for things such as the keyboard and the mouse. And we learnt that there's two different input events. There's action events, which is for simple pressed and released input, and there's axis events, which continuously fire and send an input value. However, we can create our own input mappings that can be bound to multiple inputs, and we can even give them a name. For example, we can have a single input event for moving the pawn forwards and backwards, and we can name it appropriately. So how do we access and create our own input mappings? Well, we do this in the project settings. We can come up to Edit, and then Project Settings. And there's different categories on the left. Under the Engine section, we can find Input. And here at the top, we can find Bindings, which is where we create our input mappings. So let's just take a moment to think about what we want to create. I want the player to continuously move forwards or backwards, depending on if we press W or S. And we want them to continuously move right or left depending on if we press D or A. So we know that if we want an event to continuously fire, we want to use an axis mapping. So let's add a new axis mapping in, and let's expand the axis mappings by clicking this arrow. This is the new event we've just added in, and we can rename this. We're going to bind two inputs to the same event, so let's name it something like move forwards / backwards. And we can expand the event to choose the first binding to the input. Let's start with moving forward, so I'm just going to drop this down and type in W to search for the W key, and we can just grab that there. Now we have input scale here. When I hold W down, I want the input scale to be 1, representing moving forwards. And we can add another input bound to the same event by hitting the plus icon next to the event name. So I want this one to be the S key, but when I press S, I want it to be -1 for the input scale. This way, the direction of our movement will reverse, making us move backwards. But I'm going to let you have a go at setting this and the rest of the inputs up. So your challenge right now is to set up your input bindings for move forwards and backwards. I recommend to use the W and S keys for this, and then for move right and left, and I recommend to use the D and A keys for this. And make sure to set the input scale for each binding. So pause here and have a go at it, then in a moment I'll take you through the process. Okay, so to do this, I first want to make sure my input scale is set correctly for my S key. I'm going to change this to -1. And now we want to set up the new axis mapping for move right and left. So I'm going to add in a new axis mapping by hitting this plus icon here. And we can add in a name for this, move right/left. The first mapping is going to be my D key. And the scale is going to be, we're going to leave the scale at 1. And we're going to add in another input binding. And this is going to be for the A key. And the scale here is going to be -1. Okay, we don't need to compile or anything here. We can just close the project settings to return to our player pawn. And we can find our newly created input axis events by right-clicking in the event graph, and we can come to the input category, and we can come to axis events, and here they are. We can grab move forwards and backwards, and then we can right-click again and come to input, and then axis events, and grab move right/left. Okay, so we have our input events ready to set up our movement functions. And that's exactly what we're going to be doing in the next lesson. So when you're ready, I'll see you there. Hello, in this lesson we are going to be applying forces to our mesh component to cause it to rotate. We're going to be working with torque. In this lesson we're going to be learning all about it and breaking it down. So when a player sends input to our player pawn, we want it to react and move based on the player's intended direction of movement. But remember, we aren't just moving it, we have physics applied to our mesh component. So instead of our mesh just magically floating, we want it to roll towards the direction that the player intends to move. So to do this, we want to apply a rotational force to the mesh. Torque is a force that can cause an object to rotate about an axis. You can refer to it as adding a torque to an object, or just simply adding torque to an object. In our case, we're going to be adding torque to our mesh. But to simplify it, when you hear torque, you can think of a rotational force that will cause our mesh to rotate. We're going to be breaking it down throughout this lesson. Now let's just start out with the idea of rolling the mesh forwards and backwards with our input axis event that we created in the previous lesson. How do we go about applying torque to our mesh component in this event graph? To get started, we need a reference on our event graph to the actual mesh component. This is really easy to do. On the components list, we can find the mesh component, and we can just simply click and drag and release it onto the graph to create a reference to it. And with the reference, the blue output pin here, we can drag it out and release it to call a blueprint action. Now torque is a physical force, so we're going to scroll down to the physics category here, and when we expand this, we find functions relating to physics and forces, and about 10 functions down we find the torque functions. There's two different methods here. There's adding torque in degrees or adding torque in radians. While developing our prototype, adding torque in degrees gave Ben and I some unexpected results. So for now, let's just select add torque in radians. Looking at the function, we can see there's many different inputs on it. We have the target, and the target is telling us what component the torque is going to be applied to. And of course, right now this is our mesh component. Below this, we have an input named torque, and this is a vector. We know it's a vector because we can see it's giving us an x, y, and z value to work with. But not only that, in blueprints, vectors are color-coded yellow. Let's just put all of our focus into this vector input right now. When we hover over torque, it says torque to apply, direction is axis of rotation, and magnitude is strength of torque. Wow, okay, so if you don't understand how torque works, this statement might seem quite confusing or overwhelming, but don't worry, we're going to start breaking this down together right now. In Unreal, when you add torque to a mesh, it will begin to receive an angular acceleration. Imagine for a moment that our mesh is a wheel. We can visualize our X, Y, and Z directions. We know that X is forward in Unreal, so if we want to roll this wheel forwards, what would the torque direction be? You might naturally choose X as the direction. Because X is forward in Unreal, you might think that if we add a torque in the direction of X, our wheel will also roll forwards. Well, this isn't what would happen. Remember, in Unreal, the function told us that direction is axis of rotation. So what would happen? Well, let's visualize our rotation axes. We can see that the x-axis of rotation for our mesh is here. If the torque direction is x, this would result in an angular acceleration being applied along the x-axis of rotation. The mesh would begin to roll on the x-axis of rotation. Okay? Let's look at another example. Let's say we add a torque in the z direction of our mesh. Our z-axis of rotation is here. So what would happen here? Well, an angular acceleration will be applied along the z-axis of rotation. The mesh will begin to spin. Okay, so if we want the mesh to roll forwards, we would add a torque to the mesh along the y direction. And we select the y direction because we would then cause an angular acceleration along the y-axis of rotation, causing the mesh to roll and move forwards. So just remember, when we add a torque to a mesh, the direction doesn't mean we want it to move in that direction. The direction is the axis of rotation along which an angular acceleration will be applied. So if we want to roll and move the mesh forwards, we know that we can add a torque to the mesh in the y direction. We would make use of the y value on this vector to do this. Now, remember, I said this vector does two things. We can hover over torque, and it says direction is axis of rotation. This is the first thing that we've just covered. And the second thing is magnitude is strength of torque. Right, so this is saying that the values that we put into this vector also affect how strong the strength of the torque is. The larger the value we put in here, the stronger the force applied to our mesh will be. But remember, we want to add torque based on the player's input. We want to make use of our move forwards and backwards input axis event. If we press W, we want it to roll forwards. If we press S, we want it to roll backwards. So let's hook up the execution pin into the add torque function. Now, this isn't yet going to respond to the player's input because we haven't made use of the axis value on the event. We want this to affect the Y value of the torque. Now the torque is still a vector, but we can split this apart to gain access to the X, Y, and Z values just by right-clicking on the pin and hitting split struct pin. And we can plug the axis value from the event directly into the torque Y input. Now let's just come back to the level and hit play, and let's see what happens. We can press W and we can press S, but look, it doesn't look like anything's happening. And this is because the torque units we are dealing with have to be pretty large to take effect on our mesh. Let's stop playing and come back to the blueprint. The axis value on our event changes depending on our input. If we hold W down, the axis value is going to be 1. If we hold S, the axis value is going to be -1. Okay, so the value flips if we hold S, meaning the torque direction will be flipped, and as a result, our mesh will roll backwards. But as we've just seen, our mesh doesn't even move, and we need these values to be larger in order for the force to take effect on our mesh. The units we are dealing with are incredibly small. The units are in Newton centimeters, and the mass of our sphere is going to affect the units we need to use. But we're not going to worry too much on the exact units we need to use or on the mass of our sphere. Right now, we're just going to tweak the value to get the result we want. So how do we tweak it to get a larger result? Well, we can multiply the axis value before we plug it in to the Y input. And this is where you come in. So your challenge right now is to multiply the axis value of your move forwards or backwards event and try tweaking the value to see if you can get your mesh to roll forwards and backwards. And once you've done that, why not make use of your move right and left axis event and try make your mesh roll right and left by adding torque. You'll have to find the torque direction to use to do this. And to help you, you can drag in a simple shape at any time and make use of the transform tools to help you figure it out. Or you can just rewatch an earlier part of this lesson to help you decide. So this might be a tough challenge. Pause here and give it a good go, and in a few moments I'll walk you through the process. Okay, so we want to multiply our axis value. We can drag it out and we can put in the star sign or asterisk, and we can grab the float multiply float and then plug this output directly into the y input on the add torque in radians function. Now, the larger the value we put in here, the stronger the force is going to be. And if you had a go at the challenge, you'll notice you need to put an incredibly large number in here to see an effect. I'm going to put in 1 million. Now if I come back to the level and hit play, if I hold down W, I'm rolling forwards. If I hold down S, I start rolling in the opposite direction. Great. So let's have a look at rolling right or left. Now we first need to determine the torque direction. We can do this by dragging out a cube, and when we have this cube selected, we can see our translate tool. We can imagine these are the torque directions. For moving forwards, we used Y as our torque direction, and if we switch to our rotation tool by pressing E, we can find the Y axis of rotation. If we rotate it on the Y, we can see what's going to happen when the angular acceleration gets applied. If this was our sphere rolling on the ground, it would roll forwards and backwards. So we can repeat this process to figure out the torque direction for moving right and left. If we chose X as the torque direction, we should be looking at the X axis of rotation. Imagine that angular acceleration being applied here on our sphere. It would be rolling right and left. So we'll choose X as our torque direction. So let's come back to our player pawn, and let's grab another mesh components reference. We can drag this out. We can come down to physics and grab the add torque in radians function. Now we want to use the X value on the vector. We can right click the yellow pin and split it to gain access to X, Y, and Z. And we want to plug the axis value into this, but first, remember, we want to multiply this. We can grab the float, multiply float, and we can plug the output of this into the X input on the torque function, and we can use the same number we've used above to increase the amount of force that is generated when we add the torque. And we just need to hook up the execution pins. Now if we come back to the level and hit play, we can go forwards, we can go backwards, but notice here if we try to move right by holding D, we start going left. If we hold A, we start going right. Okay, so what do we need to do to fix this? Well, we need to invert the value that we are using as a multiplier for the strength of torque. There's 3 different ways we could do this. We could simply change the input value to negative 1 million, or we could multiply this again by negative 1, which would invert it. But there's one more way I want to show you by changing the scale values of our input bindings. We can come to our project settings and we can head into the input section. And where we have our move right and left input bindings, we can change the scale values here. D is 1, so we can change this to negative 1. And A is negative 1, so we would just make this 1. And by doing this, we are inverting the axis values. So now when we come back to our level and hit play, we can roll the player pawn forwards by pressing W, we can roll backwards with S, we can roll right with D, and we can roll left with A. So we have achieved this by making use of the add torque in radians function. We are multiplying our input axis values by a number to give us a larger force. Now this number is known as a magic number. We haven't made it totally clear what it does in our blueprint code. So in the next lesson, we're going to be making this clearer by having our first introduction to blueprint variables.